Okay, let's practice. How do you know this is a hyperbola? And how do you put it in standard form? And obviously we're going to have to complete the square here. But let me say, I know this is a hyperbola because both the x and the y are squared, and one of them are different. Notice this is a positive 9, and this is a negative 4. So because one's positive and one is negative, I'm going to know it's a hyperbola. So when you complete the square, you want to put the positive term first. It has nothing to do if it's an x or a y. You want to put the positive term first. I notice there's no other y's, so that's good for that one. And then I'm going to put my x's. There's this negative 32x here. And then all my constants, I'm going to move to the other side. So if it's a negative 100, when I move it to the other side, it's going to be a positive 100. Now, this one's just fine. So I'm going to leave him alone because there's nothing like to the first power, y to the first, like there is right here. Like there's an x to the first. So I'm going to complete the square of this one. Remember, this has to be a 1 right here, so I'm going to factor out a negative 4. When you factor that out, be careful and watch the sign. When you pull out a negative, it's going to make that a positive 8x. And you can see that negative 4 times 8 is negative 32. Okay, I'm going to leave a little space right there. Now, you do this just like always. You half it, you square it. So half of 8 is 4, and if I square it, I'm going to get 16. So I'm going to go ahead and carry down here what I have. I don't want to lose him. And I've got this. Now look what you just did. You didn't just add 16. If you would multiply that negative 4 in, that is a negative 64. Whatever you do on the left, I need to do it on the right. So I'm going to do that right there. So this is a negative 64 on the left, so I'm going to do a negative 64 on the right. So what I have right now is, I want to write this as something squared. Remember, this is x plus 4. The easiest way to do that is half of a positive 8 is a positive 4. Some people like to think, what's the square root of 16? And then just keep that sign the same. And 100 minus 64 is what, 36? Now, you are almost done, except if it's a hyperbola or an ellipse, this has to equal 1. So what I'm going to do here is divide everything by 36. So I'm going to divide this by 36 and divide this by 36. So I can see here 9 will go into 36 4 times. Sometimes, I'm just going to tell you, especially on the math you see, it doesn't divide out so pretty, and you're going to be left with fractions, and that's okay. 4 goes into 36 9 times. So you have x plus 4 squared over 9 equals 1. Okay, so this is my hyperbola in standard form, and that's what I'm asking you to do. My center of my hyperbola, I can see, would be negative 4, 0, because remember, it's what makes the numerator 0. Be really careful. A lot of people will get these switched, but remember, this is an ordered pair, and your x always comes first. So find the value for the x that makes it 0, and then the y. All right. If I was going to graph this, because the y comes first, it's going to open up or down. So I ask you that as well. It's going to open up and down. Okay. I'm trying to think what else I've asked you other than the fact that it is a hyperbola. Remember, if I was going to graph this, you want to start with your center, which is negative 4, 0. 1, 2, 3, 4, negative 4, 0. This tells me how far, since it's under the y, I want to go up and down. So I want to go up and down 2. So I'm just going to do this real quick here. So I'm going to go up and down 2. So there's 2. I'm going to go down 2. This tells me I want to go back and forth 3 because it's under the x. We know the x-axis goes back and forth. So I'm going to go 1, 2, 3. 1, 2, 3. If this is an ellipse, I'd be done, but it's not. It's not hyperbola. So I'm going to do my little box right here, my little rectangle. Okay. Then put in your asymptotes. And remember, your asymptotes need to go through the corners and extend it all the way. It's going to look something like this. Okay. So it looks like this. And then because the y comes first, has nothing to do with what's in the denominator. It's all about who comes first. I know it will open up and down. The points here on your box, those are your vertices. So it's going to look something like this. Just a nice smooth curve. The only place it should touch on this magic box is that one point. And I am looking through my phone, so it does make me a little shaky. And remember, it needs to approach or get close to your asymptotes, but it will never touch it. So it's going to look something like this. So here's your vertices right here. So if I ask you your vertices, for me, you can either look at the graph and just kind of count and see what point that is. I always like to look at my center, and I knew it went up and down 2, which affects my y value. So one time I'm going to add 2 to this, so it's going to be negative 4, 2. And the other time I would subtract 2. So those would be my vertices right there. So that should be it, okay? Let's do one more here. This one's a little bit more interesting. Again, I know it's a hyperbola because both the x and y are squared right here, and one is positive and one is negative. So I know it's a hyperbola, definitely not in standard form. I'm going to put the positive one first, okay, just like we did here. I chose the 9y squared to put first because he's the positive one. Here, it just so happens my x squared is positive, so he's going to go first. And I'm going to put the negative 64x beside him. So I want my x's together. I'm going to leave some space. I want to put my y's together. And then my constant already happens to be over here. If it's not, move it to the right. Okay, so when I complete the square, remember this has to be a 1. So I'm going to pull out my 16. 16 goes into 64, what, 4 times? Okay, so I'm going to half it and square it. So half of that is what, 2, and if I square it, I get 4. Now look, you didn't just add 4, you added 16 times 4, which is 64. So what I do on the left, I've got to do it on the right. So I've got that over there. I'm going to do the same thing here. This is what's tricky, is because now I'm pulling out a negative 9. So you've got to be really careful here with your signs. But negative 9 will go into negative 54 6 times. And just double check. If we multiply that back in there, do you get the same thing? Here's where you add your magic value. Half of 6 is 3. You square it, you get 9. That gives me what? A negative 81. So I've got to make sure I put a negative 81 on this side. Okay. When you add all those values together, what do I get? 144? I'm pretty sure. I'm sitting here trying to do that math real quick, and it's not funny, but I think that's 144 right there. All right, so this is going to give me 16x minus 2 squared, because half of negative 4 is negative 2. This is going to give me what, y plus 3 squared. And you can see the 3 squared gives me 9. Half of 6 gives me 3, so that works. Okay, I am almost done. The only problem is this is supposed to equal 1. So I have to divide every single thing by 144. Sometimes these will go in evenly, sometimes they won't. If they don't, you know, just leave it like it is. But 16 does go into that 9 times. 9 goes into that 16 times. So my standard form is x minus 2 squared over 9 minus y plus 3 squared over 16 equals 1. And there I go. That is your equation for the hyperbola in standard form. And here's what I know. I know my center is 2, negative 3, because that's what makes it 0. I know it opens left to right because the x comes first. All right, so I could do that real quick, but I think that's good enough for now.